Example, determining constant c such that f of x is continuous. So what does it mean to be continuous? Hopefully we have memorized this or we remember it. F of a must exist, so some value, what we're interested in. The limit as x approaches a of f of x must exist. And whatever these two values are, they need to be equal. Alright, so they told us f of x is continuous. Therefore, I know f of some number exists, right? Well, the first piece of my piecewise is a polynomial. The second piece is a polynomial. I only need to investigate when x is equal to 1. So does f of 1 exist? And your answer is yes, because look, when x is equal to 1, we have a function value. We can plug 1 in for it. We'll get an answer. Okay. Now, we do see that c is in that part, and we don't know the number for c, but we're going to use the limit part to help us with that. Alright, so now let's look at the limit as x is approaching 1 of the function. And just like before, we know for piecewise, we have to look at this limit as x is approaching 1 from the left, and the limit as x is approaching 1 from the right. Well, approaching from the left, our values less than 1, so that's the first piece, which is x plus 1. Approaching from the right, our values greater than 1, so that's 2x plus c, which is the bottom piece. We'll do direct substitution, so we'll plug directly in for x, and we get 1 plus 1, which is 2, and we get 2 times 1 plus c, which is 2 plus c. Remember that these two limits must be equal to each other in order for the limit as x approaches 1 of the function to exist. Therefore, I have an equation that says 2 is equal to 2 plus c, and then I can solve this for c, and I get c to be 0. So I can rewrite my piecewise function real quick, and I end up with x plus 1 when x is less than 1, and I end up with just 2x when x is greater than or equal to 1. So this function is continuous everywhere, and you can test it out by determining if f of 1 exists, meaning does it give you a value? Does the limit as x approach 1 of f of x, does it exist? Meaning approaching from the left and approaching from the right, does it go to the same function value? And then lastly, is the limit, whatever value we get for the limit, is that equal to f of 1? Alright, so good. This was another example showing how to determine constants if we know the function itself is continuous.